time, and at the same time, the distance from the y-axis, this point, until the center is also the radius. The distance from the center to the point where it touches the line, the circle, the line touches the circle, is also the radius. So these are three important information that can help us. And for that matter, the center of the circle is going to be at R. So that will be where the center of the circle, that's where it will be located. So now that we have this, we know we can now find the length from C to A. So if we are to find the length from C to A, that takes us to this slide. Now before, maybe I also say this. If we have a line like this, and you want to find the distance between the line and a point, that will be the perpendicular distance. Remember, this line, the equation of this line was given to be 8x minus 15y equals to 120. So if this is our point C and this is point A on the line, now see if the coordinates of C is AB, then the distance AC is given by the modulus of 8 times A times the x coordinate of the center. Then this is minus 15 times the y coordinate of the center, which is B, minus 120 divided by, you need to take the constant on one side, divide by square root of 8 squared plus negative 15 squared, square root of 8. So this is how we obtain the distance between a point and a line. Distance between a point and a line is given like this. That's why we can see that in our work, we have AC. The length AC is given by 8R minus 15R minus 120 over the square root of 8 squared plus negative 15 squared. So that's how we get this. That's how we get this one here. So when we simplify, first of all of them, negative 8 minus 15 is negative 7, then negative 120. When we pull out negative and we get the modulus, we drop the negative. We remain with the 7R plus 120 out of 17 equals to R. The distance AC is R. So for that case, when we do manipulation here, we cross multiply by 17. We get 17R equals to 7R plus 120. So when we simplify, we get R to be equals to 12. And having obtained R, we can now write the center. Remember, the center is at C with the coordinates R. So this one more step. That's how we obtain the center of the circle to be center of the circle to be at 12, 12. So that is the center of the circle. Now we remain with the finding the equation of the circle. The radius is 12. The center is also at 12, 12. So as I said earlier on, yes, Mark.
Thank you, sir. Teacher, I didn't get the part where we got the modulus of R. We have negative 7R minus 120 over 17. And then we come to 7R plus 120. I didn't get that part.
Okay, thank you. Now for this part, remember this, we have modulus of, when we pull out the negative, we shall have negative 7R plus 120 over 17. Are you there? Now, remember the other time I gave example using 3. I said if you get modulus of negative 3, then the result is 3. Which means the modulus of this negative open bracket 7R plus 120 is the same as this one here. Have we followed now? Mark, you got it?
Yes, sir. Thank you so much. Yeah.
Okay, you're welcome. So that is how we can determine the value of R. After we have obtained the value of R, we can now write the center. Remember, the center is at R. So the center will be at 12, 12. We can proceed to find the equation of the circle now. So since we know the radius, we know the center, we can now express the equation of a circle. Remember equation of a circle when I gave you earlier on at that time. So when you have maybe illustrate again before we proceed. If you have a circle with its center E, then if the radius of the circle is R, then X minus A squared plus Y minus B squared equals to R squared. So this is what we have used here to write this expression or this equation. So that is the equation. And when we expand, we get x squared minus 24x plus 144 plus y squared minus 24y plus 144 equals to 144. 144, this one cancel the other one. We remain with 0 on the right hand side. So when we collect the like terms, we get this as the equation of the circle. So the equation of the circle is x squared plus y squared minus 24x minus 24y plus 144 equals to 0. Now the circle touches the axis at, you write the coordinates at the x-axis, which is 12, 0, and also the coordinate at the y-axis, which is 0, 12. So those are the points where the circle touches the axis. I think because of the change we made -8 there, the illustration will be slightly different. Because what I sketched was using 8, 8, 0. I mean 0, 8 and 15, 0. So you need to take note of that. So the illustration, our illustration, this is what I'm talking about. In our diagram, the illustration there should change. Sorry, my thing is slightly slow. I wanted to get back to here. Here. Here, this line will change because we have here to be -8. This one, y equals to -8, which means the line will not go in this way. You need to draw correctly using the axis, using these 2 points, -0, -8, and 0 and 15, 0. 0, -8 and 15, 0. So the line will be different from what we have here. You just need to take note of the points and you can easily draw them. So that is for number 2. Maybe probably again show you the questions for number 3 before we can work on it. So I'm going to stop this sharing so that we can see the question for number 3. Question 3. Question 3 is determine the maximum value of 6 cos x minus 3 sin x. That's 3A. B, prove that cos 20 degrees plus sin 20 degrees over cos 20 degrees minus sin 20 degrees equals to tan 65 degrees. And C, in a triangle ABC, prove that sin B plus sin C minus sin A is 4 cos A over 2, sin B over 2, sin C over 2. So this is the question we are going to handle now, question 3. Then also, maybe you can have this question number 4 so that I don't come back here again. Question number 4A is saying express x squared plus 5x plus 11 over into x plus 1, close the bracket, x squared plus 4 in partial fractions. And then later we evaluate this partial fraction from 1 to 4. We want to integrate from 1 to 4 with respect to x. So these are the 2 questions which we are supposed to discuss. I hope you have taken notes so that I can go back to our slides. So on our slides, we get back. So number 3. Now, to get the maximum, we need to express this function in the other form. And now that this is negative, between cos and sine here, cos and sine, this part is negative. So it means you should have r sine x minus beta. If this was positive, then this will also be sine x plus beta, like that. This is from compound angle formula. Compound angle formulae. That's where you generate this. So with trigonometry, you really need those identities in order for you to solve the problems. So when we expand R sine x minus beta, you know, sine of x minus beta is sine x cos beta minus cos x cos beta. So that is the expression. Now, when we compare this, when we open up, we take R inside, we open up these brackets, and then we compare. When we compare, comparing, you can see that this R and cos beta are constants, this one. So we equate to coefficient of the coefficient of cos sine x, which is supposed to be 3. Then this one, R sine beta will also be constant. We can equate. So after doing that, we can solve the two equations simultaneously. If we divide equation 2 by 1, we get sine beta over cos beta. R will cancel. When R cancel, we remain with tan beta equals to half. And from here, I think I've reversed. Okay, from here, when you do this, you get beta to be a half. I mean, tan beta equals to a half, and beta is arctan of a half, and arctan of a half is 26.57 degrees. So this is our beta. We now need to also find, R. To find R, you need to square the two. You square the two equations. Square the two equations. We have R. We have R sine x. I mean sine beta. This one square plus R cos beta squared equals to 3 squared plus 6 squared. So we get R squared into, when we square this, we get sine squared beta plus cos squared beta equals to, this is 3 squared 9, 9 plus 16, 25. So, I mean, 9, this is 45. This 9 plus 36. 9 plus 36 will give us 45. So this is 45. But sine squared beta plus cos squared beta is 1. This one gives us 1. That's why in the solution, you see it has disappeared. We have R squared equals to 6 squared plus 3 squared. So R is square root of 45. Then 6 cos x minus 3 sine x will now be root of 45 sine of x minus 26.57 degrees. So from here, we want the maximum. The maximum value this function can attain, the maximum value sine can attain is 1. And the minimum value it can attain is -1. So, but here they want us to get the maximum. So for that case, we need to multiply root of 45 by 1. And when you compute this from your calculator, it gives us approximately 6.78. So that will be the maximum of this. If they want the minimum, for minimum, you need to multiply this by -1, since the maximum, the minimum value sign can attain is -1. And it's the same with cos. If you had put the expression in terms of cos, you can also determine the minimum and the maximum in the same way. So that is for the maximum and minimum. That is for number, that's part, I think that's part A. Then part B, we want to prove that, or maybe if anyone has a question on the previous work, can do. If you have any questions on the previous work before we proceed, you are free to ask. Yes, Mark.
Yes, sir. Teacher, for the previous number,
Yeah.
you find that for some questions, like when you use negative, you get a maximum, and when you use a +1, you get a positive. So how do we distinguish between the two? Should we like use both of them and then get which gives us a maximum, or?
No, now, because if we are to use maximum, mean there should be a negative now, a negative before this, a negative, the minimum gives you a positive, and that will become the maximum. Let's there is some negative.
Excuse me, sir. I can't hear you.
Me too, I'm not hearing anything.
Can you hear me now? Hello?
Yeah, but we can hear you.
Okay, thank you. Now, I was saying we want to prove that cos 20 plus sine 20 over cos 20 minus sine 20 equals to tan of 65. So we need now to divide all through by cos 20. When we divide all through by cos 20, the one I have highlighted here will be 1. Because cos 20 over cos 20 is 1. Meanwhile, sin 20 over cos 20 is tan of 20. Cos 20 again out of cos of 20 is 1 minus again tan 20. But we know tan of 45 equals to 1. Since tan of 45 is 1, we can replace this one here, which I highlighted, this one here, can replace it by tan of 45. And from when you get back to compound angle identities, what we have now, tan of 45 plus tan 20 over tan 45 minus tan 20 is the same as the tangent of the sum of the angles. So we just sum 45 and 20 and to give us the result, which is 60, tan of 65. So that is for part B. If you have not got it clearly, you can still ask. If anyone asks any question there, if not, we proceed. Okay, I think we are all covered. If we are all covered, we move to the next part. So the next part, that is part C, we want to prove, okay? Part C, we want to prove that given that A, B, C are angles of a triangle, we want to prove that sine B plus sine C minus sine A equals to 2. Equals to 4 cos A out of 2, sine B out of 2, sine C out of 2. That is the question. So when we take the left-hand side, we can group this into 2. We group this. When we group this and we use the factor formula, when we use the factor formula, it gives us 2 sine B plus C out of 2 cos B minus C out of 2. That's for first part. Then for this second part where we have sine A, you use double angle identity for sine. Remember sine 2 theta equals to 2 sine theta cos theta. So in this case, our 2 theta is represented by A. So it means theta is A out of what? 2. A out of 2. That's how we have got this part. Meanwhile, the first part here, we are using the factor for sine plus sine. So that is how we expand. Expanding, we need to do something again, and that is to say, remember, ABC are angles of the triangle, meaning A plus B plus C is equals to 180 degrees. So for this case, B plus C equals to 180 degrees minus A. So if we divide this by 2, also this side by 2, we remain with it 90 minus A out of 2. So when we apply this, that's why we have this part now. Sine. So sine B plus C will be equal. B plus C out of 2 will be equal to sine of 90 minus A out of 2. But also, another thing you should know is that when you have sine, when you have sine 90 degrees minus theta is the same as cos of theta. That's why we have now moved from this part to this one here. That's how the cos A out of 2 has come about using this relationship, using the relationship here and putting star. So after doing that, you can see when we go and substitute back, when we substitute in our equation, in the equation above, we get this. Let me erase. We are substituting up here. We get, which means here, maybe I write something, be clear. We have gone back to this expression, which means now sine B plus sine C minus sine A equal to that, equals to this. There is a common factor, which is cos of A over 2 and cos A, and then also 2 and 2. So we pull out the common factor. Then inside the bracket, we shall have cos B minus C out of 2 minus sine A out of 2. So that is, now we again need to do something to the bracket. You can see the bracket. We need to do something again. Remember we did something here. So A out of 2 again, A out of 2 is again the same as B plus C out of 2. A out of 2, A over 2, A over 2, this one here. A over 2 is going to be, okay, not the same. There's some, let me show you what happens here. I'll show you what happens. So A out of 2, remember, B plus C out of 2 equals to 90 minus A out of 2. So if we have sine A out of 2, remember sine A out of 2 is the same as cos of 90 minus A out of 2. But 90 minus A out of 2 is the same as, so this is cos of B plus C divided by 2. So that is the next thing we are going to do in the next step. I've shown you in advance, but that is in the next step. I've shown you so that you understand what is going to take place there. So we can move to the next slide, which contains what I've just illustrated here. Sorry that I've already erased, but we will see it. You're going to see it in our slides here. Okay, here. So we can see I've brought back here B plus C out of 2. So when we express this again in using factor formula, remember this is cos minus sine. We can have this simplified to negative 2 sine B sine C. I think there's an error here. This should be cos. You take note of this. This should not be sine. This should be cos. So cos minus cos is negative 2 sine sine. That is from the factor formula. So this, we shall have this plus that, B minus C out of 2 plus B plus C out of 2, divide by 2 again. B minus C out of 2 plus B plus C out of 2, all of this divide by 2. But when you simplify this, it reduces to B out of 2. C is negative, and here is positive, so C will cancel. Meanwhile, when you subtract, this reduces to B out of 2. Meanwhile, when you subtract here, you subtract. When we subtract minus that, divide by 2, all of this divide by 2, it gives a negative C out of 2. So that's how we have got B out of 2, sine B out of 2, sine C out of 2, negative here. But we know another important thing to note here is that, let me clear this, and I also illustrate. Another important thing to note is that when you have sine of negative angle is the same as negative times sine of the angle. So that negative here, when it comes out, it neutralizes this negative before 2 inside the bracket. So 2 times 2, we get 4. Then all these are products, you just put them together and it brings you the result as required. So that is for the proof. It's still open for discussion. If you have any question, please feel free to ask before I move to the next part. Meanwhile, you take note. This part should be, take note, this part should be cos, not sine. It was typing error. I saw Mark, you have concern?
No, not really. Not really.
Okay. So we can proceed to the next part. Number 4. Remember, number 4 required us to express this fraction in partial fractions. In partial fractions, we have different types. We have types where you only have linear function in the denominator. We have also another type where you have quadratic function in the denominator. And we have also another type which is having repeated factor in the denominator. So when you look at this particular case, it is a mixture of linear factor. This part is linear, the first part. Meanwhile, this other part is quadratic. Then another thing to note here is that before you can express this in this form, ensure that the upper fraction, the upper number or expression has a lower degree than the denominator. If they are of the same degree or the numerator has degree more than that of the denominator, then that will be called improper fraction. So this only works for proper fraction. Fractions where the numerator has lower degree than the denominator. The degree, by degree here, we mean the highest power of x. And when you look at this first part for the numerator, the highest power of x is 2. This one, where we have x squared. Meanwhile, this one, the lower part, that is the denominator. The degree is going to be 3. Because when we open up these brackets, we're going to have x cubed. So x cubed means the highest degree, mean the degree of the polynomial in the denominator is 3. So this fraction is proper. So now that is a proper fraction, we can express it in the form of a constant over the first factor, since the first factor is linear, plus bx plus c over the second factor, which is quadratic. Now that this is quadratic, you need to write in the numerator a polynomial of degree less than the denominator by 1. That's why we have now bx plus c, because the numerator has degree 2, mean the numerator should have degree 1. And here you need to put equivalent sign first. So the fraction is equivalently written as a out of x plus 1 plus bx plus c out of x squared plus 4. So when we manipulate the right hand side, we get the LCM, which is x plus 1 times x squared plus 4. That is the LCM. Then we express the numerator basing on the LCM. So the numerator, that is x squared plus 5x plus 11 will be equals to a times x squared plus 4 plus bx plus c times x plus 1. One of the techniques to find the values of a, b, c is to put suitable numbers in place of x. I prefer this because it is shorter. In other words, you can also expand the right hand side, and then later you equate the corresponding coefficients. The coefficient of x squared to that of x squared, the coefficient of x to that of x on the right hand side, and the constant to the constant. But here, trust me, it might take you longer. I'm not discouraging you, but you can still use it if you feel comfortable. Because here, the thing is, you should be able to do this number in the shortest time possible using the easiest method for you. So that is another method. Just expand this, then you equate corresponding coefficient. So when we substitute for x equal to -1, we get x squared plus 5x plus 11 gives us 1 minus 5 plus 11 equals to 2a. This one, when you put -1, the second part of the right hand side will disappear because you are multiplying it with a 0. So this gives us I think I'm seeing an error here. We are putting -1. If we put -1 squared, -1 squared is 1. This should be 5. Sorry, it's not 2. This should be 5a. This was typing error. I correct. It was typing error. This part is 2. It's 5a. Hope you have got it. This part should be 5a. I'm talking about this. Let me write. This will be 5. A. So from here, you get A to be 2. Then the same way, when you put x equals to 0, remember A is already 2. So for A, 11 equals to 8 plus C. So we get C to be 3. Putting x equal to 1, we get 1 plus 5 plus 11 equals to 10 plus 2b plus 6. Because C is already 3. So it gives us 6. And from here, we get B to be equals to 2. To avoid making errors, it's better you, because we are substituting here, it's better you, if you are putting -1, you can first substitute all of time -1 squared plus 5 times -1 plus 11 equals to A into -1 squared plus 4 plus B into -1 B to -1 plus C, then -1 plus 1. You better do this so that you avoid errors. So when we do this, we get A to be 2, B is 2, C is 2. So that is for the constant. We need to determine them as we have stated here. So after you have obtained the constant, you go back to the fraction and express as it is required. So we now come back here. We have got A, B, and C, which means the partial fractions can now be written as that. The partial fraction is going to be 2 out of x plus 1 plus 2x plus 3 out of x squared plus 4. So that is what we are supposed to express in partial fractions. Okay, maybe before I can proceed any further, remember I told you we have different types. If you have, for example, repeated, let's say we have 2x minus 3 out of x plus 1, x minus 1 squared. Then this is where we are talking about the repeated factor. X minus 1 is repeated. So in this case, for the first part is linear, it's going to be A out of x plus 1 plus this repeated factor is also linear. We shall have B over x minus 1 plus C out of x minus 1 squared. So that's where there is repeated factor. That's what you do. For quadratic, I've already talked about it. But another thing that I want to also express here before we move away is that sometimes they give you improper fraction. And when you are given improper fraction, you need to be careful. Don't rush to, for example, fraction like this, x squared plus 2x minus 1 over maybe x plus 1, x plus 3. This one is improper. Improper, why? The degree of the numerator is 2. The numerator is of degree 2. Denominator also degree 2. And I said when they have the same degree or the numerator has higher degree, then that fraction is improper. You need to first split it. So how do we split? We can split this by doing long division. You need to carry out long division on this, and that is another aspect. Or if you have a fraction like this, if you have a fraction like x cubed plus 1 over this fraction is also improper because the degree of the numerator is 3, the degree of the denominator is 2. Since the degree of the numerator is higher than that of the denominator, this fraction is improper. So in this case, you again have to express. You can do long division, or if you are not comfortable with long division, then this is what we do. Because long division sometimes is challenging to students since we are dealing with number and letters here. So what you do in this particular case, you're going to be equal, let this be equal to. Now you get the difference in the degrees. This is degree 3 minus degree 2. Degree of the numerator is 3, degree of the denominator is 2. So this gives you 1, which means you have to write here a polynomial of degree 1, ax plus b. Then plus now, we shall have, the first part here is linear, we shall have c over x plus 1 plus d over x plus 3. So that's for when you have improper fractions. So be careful before you express this in partial fractions. Be careful to note that it is either proper fraction or improper fraction. Then you proceed with your work. So that is for expressing in partial fraction. If you have any questions still, you can ask before we go to part B. Want to move to part B? If you have any concern, yes, Mesigwa. Mesigwa, can you unmute?
Yes, yes, Master. I wanted you to repeat that very explanation you have just given.
Oh, I repeat for the,
Now,
okay. The network is not very stable, but I think I got you. You want me to repeat for the other part where there's improper fractions?
yes, please.
But I maybe before you unmute, I want to ask you, you can unmute. Mesigwa, Julius,
Yes,
are you conversant with the getting the degree of the polynomials?
yes, I'm conversant, but that step where you had 3 minus 2, then ax plus b.
Okay. What we are saying is, if we have here, if we have a polynomial, if we have a fraction which is improper, maybe I have x to power 4 minus 2, like that, over x plus 1 times x minus 3, something like this. So first of all, the degree of the numerator is 4. And then the degree of denominator is 2. Because when we open the brackets here, we are going to have x squared, right? So the degree of the denominator is 2. So you get the difference between the degree of numerator and the degree of denominator. So the degree of numerator is 4, while this one is 2. So we have 4 minus what? 2. Then after you have done this, and this gives us 2, I mean, I've written. This gives us 2, not 3. It gives us 2, which means when you're expressing this fraction, you're going to let it to be equivalent to. Now you write a polynomial of degree 2. This will be the polynomial of the degree, the degree of the polynomial we should first write. So we shall have, since it's degree of polynomial 2, polynomial of degree 2, we shall have a x squared plus bx plus c. Then now, plus, you now express this one in partial fractions like we did earlier on. Since all these factors are linear, we are going to have another constant b out of the first factor, which is x plus 1. Then the second one, which is e over x minus 3. So that's when the degree of the numerator is greater than that of the denominator. We call those kind of fraction improper fractions. That's how you generate it. Otherwise, you can do this. You can do this way. Let me erase this. Then I show you another way of getting this part. Another way of getting this part here, the one of cycle, without first coming here. So if you want to use that alternative way, you need to divide the numerator by the denominator. So it means when we open the denominator, we open the brackets. We're going to have x squared minus 2x minus 3. Then you have now to divide x minus, x to the power 4 minus 1, minus 2 rather, x to the power 4 minus 2 by this one. When you're dividing polynomial like this, you simply look for a number that when you multiply by this, it gives you the first part. And that number is x squared. So x squared times this, we get x to the power 4 minus 2x cubed minus 3x. Then when we subtract, this part will go. We shall have, we are subtracting, remember, shall have 2x cubed minus 3x. Then we pull down 2, this negative 2. Then when we do this, when we divide this by that, we need here, we shall have plus 2x. Then you multiply by all of this, subtract. You can see it's now bringing the polynomial, which is in the form of ax squared plus bx plus c. There's going to be a constant here. The constant may be 0, or maybe that may be another number. So this will represent this part. Then for the remaining part, you now express the remaining part in the form of d over x plus 1 plus e over x minus 3. Those are the two ways by which you can handle this kind of problem. I think I can erase. I hope it's better now. So we can proceed to the next part.
Yes, I'm very clear there.
Okay, thank you. So let's look at the next part. I think it should even be, oh, sorry. Let me share again. Okay, we want to evaluate from 1 to 4. the partial fractions we have just obtained with respect to x. So we express the left-hand side in terms of partial fractions we have just obtained. We got 2 out of x plus 1 plus 2x plus 3 out of x squared plus 4. Then we split this into different parts using the rules or the laws of integration. We also express this. We also split this part. We also need to split where we have the quadratic here, where we have the quadratic. So we have this 2x out of the denominator plus 3 out of the denominator. So for the first part, you can see this 2 is constant, you can take it out. When you differentiate x plus 1, you get 1. So it means this part is 2 natural log of x plus 1 plus, when you differentiate the denominator here, you get 2x, which is already there. So this is natural log of x squared plus 4. But this other part takes you to inverse trigonometrical functions. Inverse trigonometrical function. Let me illustrate how 3 out of 2 tan inverse of x over 2 has come about. That's what I'm going to illustrate before we can proceed. Let me write still on this space. We want to work on this part. So to work on that part, we first let x squared plus 4 be equivalent to a squared into 1 plus tan squared, maybe u. So when we expand this side, we shall have a squared plus a squared tan squared u. From here, a squared equals to the constant, which is 4. So we can get a to be equals to 2. So a is 2. Meanwhile, I think allow me to erase this because I still need a space to write. Allow me to erase. We have got 2. Remember, a is going to be 2. Now another part is x squared is going to be equals to a squared tan squared u. That is another part. Maybe I use this part here. So we have x squared equals to this. When we take square root on both sides, remember a squared is 4. So I can replace this one by 4. Instead of writing a squared, I can now replace this by 4 so that we have x squared equals to 4. So from here you can see that sorry. We can see that tan of u equals to x out of 2. So u itself is going to be tan inverse of x out of 2. So that will be our u. Now, we are changing variables from x to u. We need to differentiate this with respect to u. We can differentiate this with respect to u. Let me clear again. Clear all this one. Then I show you how you can do this. So remember the value of a and u, the expression for u. U is arctan of x out of 2. Now we have got that u, we have got that 2 tan u equals to x. So if we differentiate this, we get 2 sec squared u equals to, here, the u equals to the x. But remember, sec squared u is the same as 1 plus tan squared u. So it means 2 times this equals to the x, this one, the u. So if we change the variable and put back here, we put back here, we shall now get this 3 is the constant up here. And when we make the x the subject, we change in terms of the u, then the 2 comes down here. So we have, because you're going to have 3 out of 2 u, but u is arctan. Remember, u is arctan of x out of 2. So that's how this part has come about. I think that is where there's a little bit of challenge, but having done this, you should be able to know how it has come. So from that, we put in the limits of integration, starting with the upper limit and then the lower limit. So when we do put the limit and simplify, we get the integral to be approximately 4.1841. So those are the questions that I've selected for our discussions today. I think let's get to question and answering session. If you have any questions in regards to what we have done, or even something which you want to inquire, something that could have been disturbing you, it is the time. So the floor is open for any reaction. You are most welcome.
Excuse me, sir.
Okay.
Under circles,
Yes.
there is a term, they say, is it orthogonal, something of that? What is the meaning and how does it apply?
Okay. Now for orthogonality, let me look for, just a minute, let me look for space. Okay, I think this one has enough space. I will use this. Maybe let me create a slide here and just a minute. I want to get to where I can write. Here again. Okay. I'm looking for space. Okay, there we are. Now, if we are talking about orthogonality, say you have two cycles. You have this. You have two circles like this, then another circle like that. Maybe this one has a center here. This one has another center there. Now, if the tangent at the point of intersection of this circle passes of the first circle passes through the center of the second circle, and this also passes through the center of the other circle. You can see that since this passing through the center, the distance from here to there is the radius of the first circle, meaning that also this is the radius of the second. So when you join these two centers, then the distance between the two centers, say this is C1 and C2, call it D. This is orthogonal, means we have a right angle triangle there. If the two meet at right angles triangle, then you can see from here that if this is D and D becomes the what? The hypotenuse. So hypotenuse squared equals to the radius squared plus the other radius squared. So this is the relationship between the radius and the distance from one center to the other. But remember, this angle should be, for them to be orthogonal, this angle must be 90 degrees. My diagram looks congested. So now when they have given you any problem here, you can use this relationship to help you simplify some of the facts that. So this is about the orthogonality of circles. Now they can give details about one circle and you are supposed to get the second circle or the equation of the second circle, something like that. So you can use this relationship in addition to other properties that you need or you know from the circle. So that's what we mean by orthogonality.
Thank you, sir.
It's okay. You're welcome. If any, is there any other concern? Let's feel free. You can just say anything. You can comment, just anything. Let's feel free. I'm seeing Remigio. Remigio, you can say something. You can unmute.
I want there back where we found the center and the radius. Where we found the equation of the circle. On the other number, was it number 2?
Okay. How to? Okay, let's get back there.
I just want to see your procedures because I came late. I arrived late.
It's fine. We also had challenges, so we had a break. I could say a forceful break because of network connection. So maybe we go back to that slide. Then I think here. This number, right? Number 2. So here we have, I think there's going to be a change in the last question because we have this line. So the line x squared minus 15, we need to sketch our problem. The problem is saying the circle touches the axis. Circle touches the axis and the radius, and I mean the center of the circle is in the first quadrant. That is touching. It's also touching the one. It's touching the axis. So I want to reconstruct our diagram because here, first of all, this should be negative 8. Because when x is 0, we have negative 15, y equals to 120. So this gives us negative 8, which means we have the point 0, negative 8. Meanwhile, for the upper one, we have the point. Okay, for this one, when y is 0, x is going to be 15. So this gives us the point 15, 0. 15, 0. So you have these 2 points for the line. Remember this circle touches the axis and its center is in the first quadrant. So we shall have the circle. It should look like this. Okay, that one is okay. But we have the point. We have the point 0, negative 8, 0, negative 8 here, and 0, 15. So when we draw, it should go like this. The line should go like this. And this one is cutting the axis at 15. It means we have the point A is going to be here. The center is there. But from the center until this point A is the radius. Similarly, from the point where it touches the y-axis until the center is another radius. And also, from the center until it touches the x-axis is also the radius. Now that you can see the distance from the origin until this point where it touches the y-axis is r. It means r becomes the y coordinate of the what? Of the center C. Center C, the y coordinate is already r. Similarly, the distance from the origin until this point is r. Meaning the x coordinate is also r. So the center of this circle is going to be r. Now we need to get r. We can get the distance from the center C until point A. So CA, remember, A is on the line. So the coordinates of A must satisfy the equation of the line. So for that case, CA become, okay, if you want to get the distance between a point and a line is given by the modulus of, remember the equation of the line is 8x minus 15y equals to 120. Bring 120 this side, it becomes negative 100. Divide by 8 squared plus negative 15 squared. This should be under square root. And this one are obtained from the equation of the line, the coefficient of x and y, the one you put under square root sign. Now the xy here will be representing the center of the circle. And since the center is r, the center is at r, it means instead of x here and y, we put there, we put r, r. So it means 8r, 15r minus that. So when you simplify this, but remember also that the distance CA is the same as R. So when you do this, you manipulate this, you come out with the value of the radius, which is 12. So that is for number 2.
Okay.
And it's important that you translate the word problems into diagrams to help you see exactly how the problem looks like. So that is for number 2. Hello? Hello? Is there any other concern? Oh. Okay. You can. Yes. Marcellus, do you have any concern? Okay, Nokia. Look, I'm also seeing this one. Nokia G21. Hello? Hello?
Yes, teacher.
Yes.
Teacher, thank you for the lesson. Mine is not on what we've been covering,
Yes.
but I would love you to explain how Macronian method of binomial expansion works.
Binomial expansion.
Yeah, binomial expansion using Macronian method.
Okay.
Yeah.
Okay. Maybe let me share my screen. That's Maclaurin theorem, right? Yes, on Maclaurin theorem.
Yes, sir.
Okay. Now for Maclaurin theorem, first of all, you should, given any function, you can let it to be f of x. Maybe I say you want to expand maybe 1 plus x or half, something like this. Okay. First of all, for Maclaurin's theorem, the formula is already there in the mathematical logbook. I hope you have seen it. Have you any time to look for that from formula? Hello? Hello? Have you seen
Yes.
that formula in the mathematical logbook? Have you seen the formula in the mathematical logbook? That's my question. Hello?
Hello?
Yes, I'm
still
saying
checking.
it. Oh, you're still checking.
Yeah.
Because with that one, it's simpler when you know the formula. In other words, the function, okay, when you have a function like this, then f of x, the expansion of f of x is given by f of 0 plus the first derivative of the function at 0 times x plus the second derivative of the function at 0 x squared over factorial plus other terms. Maybe I can write the first three like that. Have you found it? If you have failed to find it, then it is like this one.
Okay.
It's like this, but you can still find this in the what? Mathematical logbook, and you just use it.
Yes, sir. I found
So,
it.
you found it, right?
Yeah.
So, if you want to expand this example, I hope you are seeing my example.
Yes.
F of x equal to 1 plus x to the power half. So, you will now begin finding f of 0. And f of 0 means 1 plus 0 to the power half. What do we get? 1, right? See, we get 1. Then you now go and find the first derivative of the function. First derivative of the function. F prime of x. F prime of x is going to be a half into 1 plus x to the power negative a half. You there? So after that, you find f prime of 0, which is going to be a half into 1 plus 0 for a negative a half. What do we get here? It's still a half. Because 1 to power any number is 1. So we get a half there.
No.
I'm going to clear to give us space for writing. So f of 0 we have found is 1. F prime of 0 we have found is half. So I clear. We now go and again determine the second derivative. The second derivative so the second derivative of the function, remember we have already got the first derivative. Okay, it's here. I want to write it. The first derivative, we got it to be a half x plus 1 for a negative half. Meaning the second derivative now is going to be, this time this is negative 1 out of 4 into 1 plus x power. When we take away 1 from here, we get negative 3 out of 2. Then we also find second derivative of the function at 0, which is going to be negative 1 out of 4. If we put 0 here, we shall have 1 to power negative 3 out of 2, but this is still 1. So we have those terms. We now put in the formula. We put them in the formula. Let me erase this. I still remember that the first term we got, I think we got 1. The second we got a half. The third we got negative 1 out of 4. So when we now bring back and put here, I want to draw. When we put here, we get f of x equals to f of 0 was 1 plus f prime of 0, we got a half times x plus f double, this is f double prime out of 2 factorial. F double prime of 0, we got negative 1 out of 4 x squared over 2 factorial plus other terms. So when we simplify this, we have 1 plus x out of 2. Then this will be minus 1 minus x squared out of 8 plus other terms. So that's how we can apply Maxwell's theorem. You need to differentiate the function as far as the number of terms required. If they want to determine also the third derivative and be success like that until the end where you want to stop. So that is on Maxwell's theorem. And I hope maybe it's clear.
Yes, sir. Thank you so much.
If it is not very clear, you saw my contact. You can contact me anytime. Maybe send some questions to go through together.
Okay, sir. Thank you so much.
Please reshare the number.
Any other
Reshare the
concern?
number, master. Reshare the number.
Okay. Yes. Okay. I mean, those questions we discussed. Okay. Hello. I think there are no more concerns so that we can end the meeting. The next, I've seen some concern about the next bachelors. Maybe the next meeting might be next week. We shall still make the arrangement with the ministry. If they permit us to do so, we can still have another lesson next week. Otherwise, I want to thank all of you who persevered until the end. We have had a lot of challenges, but you were able to attend. I want to thank you so much. Hope to meet again next time.
Okay, sir.
Okay. Have a nice time. Otherwise, in case you have any question, you can contact me directly. You have a nice evening.
Thank you.
Thank you.
Yeah. You're welcome.